Have you ever just stopped and considered that some of the most advanced technology on the entire planet isn't found in some sterile lab or a high-tech factory, but it's right outside your window? That maybe, just maybe, the answers to our biggest engineering challenges were already solved millions of years ago? We're about to dive into a world of hidden blueprints hiding right there in plain sight.
Okay, take a look at this. The Airbus A380. This thing is a masterpiece. It's a symphony of materials science, aerodynamics, and pure computational power. It really is a pinnacle of human achievement. We built this.
But what if I told you that this incredible machine, this feat of engineering, shares a deep design secret with a shark, or even a humpback whale? Yeah, I know it sounds impossible, right? But that connection reveals a totally revolutionary way of thinking about innovation itself.
Here's what most people don't realize. We are literally surrounded by the most elegant, time-tested solutions to almost every single problem we face. The thing is, we just have to learn how to see them.
And this brings us to this incredibly powerful idea. Think of it as the 3.8 billion year R&D program. It's the concept that nature has been running the longest and by far the most successful research and development project in the history of, anything. Let that number sink in. 3.8 billion years. That's how long life on Earth has been testing, failing, iterating, and refining its designs. All of our human engineering, our few centuries of the Industrial Revolution, it's just a blink of an eye in comparison.
And there's a name for this whole approach. It's called biomimicry. It's not just a cool idea, it's a formal field of study that looks to nature's genius to solve our problems, with the goal of creating things that are way more sustainable and efficient.
Now, this isn't just about, making a car that looks like a cheetah. Biomimicry is a really rigorous engineering process. You start with a problem, and then you biologize it, which is a cool way of asking, okay, how does nature solve something like this? From there, you figure out the core principle behind nature's solution, and then you apply that to your new design.
So let's jump into our first case study. We're going to start with that surprising connection between one of the ocean's top predators and a top-tier passenger jet. On the left, what you're seeing is a microscopic view of shark skin. Now, you'd think it would be perfectly smooth, right? But it's not. It's covered in these tiny rib-like structures, and it turns out they actually reduce drag by controlling the flow of water right at the surface. So engineers at Airbus saw this and developed a special coating for planes like the A350 that mimics this exact pattern, reducing friction with the air and making the plane more fuel efficient.
Genius!
That is an incredible innovation. It's a perfect example of a small-scale solution. But this is just scratching the surface. What happens when we take this way of thinking and apply it to one of our biggest global challenges, like, say, the entire future of sustainable energy?
And that leads us to an even more amazing connection, the whale-inspired turbine. Now, we're not just talking about a little bit of efficiency. We're talking about completely rethinking the future of how we generate power.
So here's the problem. Wind turbine blades are under an incredible amount of stress. They have to be insanely strong but also lightweight, and they're constantly dealing with vibration and fatigue. Trying to find that perfect balance is a massive, massive engineering puzzle.
So where on earth did engineers find an elegant, brilliant solution to this very modern, very complex aerodynamic problem? I'll give you a hint. It wasn't in a high-tech wind tunnel.
Nope, it's in the ocean. They found it in the humpback whale, a 40-ton marine mammal that, despite its massive size, is known for being surprisingly graceful and pulling off these incredible acrobatic maneuvers.
And this is where nature's genius truly reveals itself, in a tiny little detail that, for years, scientists just didn't fully understand.
Take a close look at the front edge of the whale's flipper. It isn't smooth and streamlined like you'd expect, like an airplane wing. It has these large, rounded bumps all along it. They're called tubercles, and for the longest time, this was a total mystery. Why would an animal that depends on moving smoothly through water have bumps on its fins?
And this detail changes everything. These bumps are not a flaw, they're an absolutely brilliant feature. The tubercles work as these passive flow control devices. They actually channel the water into these tiny swirling vortices that stick to the flipper surface. This dramatically delays stalling, increases lift, and lets this massive whale make incredibly tight, agile turns that should be impossible.
And this shows you the application perfectly.
On the left, you've got a standard turbine blade design, smooth. On the right, a bio-inspired design with those tubercles along the leading edge. That one small, whale-inspired change makes the entire turbine more efficient, more stable, and it can generate power in a much wider range of wind speeds. It's a total game changer.
So what we're really seeing here isn't just a clever trick or a one-off idea. It's a huge signpost for where engineering is headed next, its next evolution.
Think about this as a shift in philosophy, right? Traditional engineering so often tries to conquer nature, to use brute force and energy-hungry materials. Biomimicry, on the other hand, asks, how can we learn from nature? It moves our thinking away from that linear, cradle-to-grave model and toward a cyclical one that's just inherently more sustainable and way more resilient. And really, that just leaves us with the final thought. We spend so much time and so much money trying to invent the future completely from scratch. But maybe, just maybe, the greatest innovations of our future won't come from a sterile cleanroom, but from simply taking a closer, more humble look at that 3.8 billion-year-old R&D lab that is all around us. The blueprints are already there. We just have to learn how to read them.
You know, we like to think of ourselves as masters of creation. For every complex problem, we try to invent an even more complex solution. But here's what most people don't realize. For just about everything we struggle with, nature already has an elegant solution that it's been perfecting for, a few billion years. And sometimes it's the simplest problems that show just how wide that gap between our tech and nature's genius really is. I mean, you've been there, right? You're trying to fix something that's wet, a loose tile in the shower, something on a boat, and even the most powerful superglue you have just gives up. It slides right off. It's this universal frustration that seems so basic, yet it is incredibly difficult to solve. But what if I told you that this little annoyance is actually a massive, high-stakes industrial headache? Yeah, this goes way beyond a leaky boat. Just try to imagine the challenge of repairing a deep-sea oil rig getting hammered by the ocean, or the hull of a submarine under immense pressure. And in the operating room, it's even more critical. Picture a surgeon trying to seal an internal wound in an environment that is, by definition, constantly wet. In these situations, a glue that fails isn't just an inconvenience. It's a multi-million-dollar roadblock that can compromise safety and completely stall innovation. And this is where it gets crazy. While we're struggling in our most advanced labs, nature cracked this exact problem billions of years ago. It's this incredible contrast between our high-tech failures and nature's quiet, effortless mastery that we're going to dive into today. And the source of this genius? Well, it's probably not what you'd expect. So, meet our protagonist, the common mussel. Don't let its humble shell fool you. This little creature is an absolute master of chemical engineering. It can do something that has left human scientists totally stumped for decades. It can create a permanent, rock-solid bond underwater while getting tossed around by crashing waves. I mean, the difference is just staggering. Our very best adhesives, they demand a perfectly clean, perfectly dry surface to even have a chance of working. The mussel, on the other hand, seems to thrive in total chaos. It latches onto slimy, wet rocks in the middle of a storm, and it just holds on for life. It's like it's defying the laws of chemistry as we understand them. And that right there is the central question. How on earth does it do it? The answer, it turns out, isn't about brute force. Nope. It's about incredibly sophisticated chemistry, a molecular toolkit that scientists have been desperately trying to understand and copy for years. To crack this code, scientists basically had to become chemical detectives. They started the long, meticulous process of reverse engineering the proteins inside the mussel's foot, literally searching for that one secret ingredient responsible for its insane sticking power. And they found it. The secret weapon is a unique amino acid called dopa. Now, the real power of dopa comes from one specific part of it, a chemical group called catechol. This tiny molecular structure, that is the engine driving the whole operation. It's the key to everything. This discovery was the turning point. It's where biology handed the baton over to chemistry. Armed with nature's own blueprint, a brilliant team at Purdue University began the painstaking work of trying to mimic it. They laid out a chemical roadmap to create a synthetic polymer, basically a lab-made plastic, that could harness the incredible power of dopa. So how does this little catechol group pull off this magic trick? Well, it's a brilliant three-step process. First, it acts like a chemical squeegee. It gets right up to a surface and literally shoves the water molecules out of the way,
creating a tiny, perfectly dry spot to bond to. Second, it forms a whole bunch of powerful hydrogen bonds with that now dry surface. And third, and this is key, it links up with itself, making the glue itself incredibly tough from the inside out. A great way to think about it is like a chemical Swiss Army knife. It's not a one-trick pony. It isn't limited to just one type of bond. It has this whole toolkit of chemical options that let it grab onto almost anything: rock, metal, plastic, even living tissue. This amazing versatility is the real source of its power. Okay, so the theory is solid. The chemistry works like a charm in the lab. But how does this little nature-inspired invention actually hold up in the real world? This is where the research got really, really exciting. First off, it's important to understand the stakes here. This wasn't just some small academic project. The Office of Naval Research poured $2 million into this research over a decade. Why? Because they knew that a truly reliable underwater adhesive would be an absolute game changer for everything they do in the ocean. So this is the ultimate test, right? It's one thing to have a clever idea inspired by a sea creature, but can it actually go head-to-head with the top commercial industrial strength glues that companies have spent millions developing for years? And the answer was a resounding yes. The results were just undeniable. When they tested it, the mussel-inspired polymer wasn't just a little bit better, it was significantly stronger. Nature hadn't just given us a hint, it had provided a fundamentally superior design. The student had officially surpassed the master. You see, this breakthrough is about so much more than just a better glue. This is one of those discoveries that has the potential to completely transform entire industries. And, believe it or not, it could even help us heal our own planet. The potential uses are almost endless. In medicine, think suture-free surgery. For marine industries, it's a revolution in underwater repair. It opens up brand new possibilities for construction in wet environments, for aerospace, for cars, you name it. But one of the most inspiring applications is already happening right now in our oceans. This is just incredible. Researchers are working with the Coral Restoration Foundation, and they're using this new bio-adhesive to attach small fragments of living coral back onto dying reefs. The glue holds them firmly in place even with the ocean surge, giving them a chance to grow and literally bring the reef back to life. A solution inspired by the ocean is now being used to heal it. And that really is the ultimate takeaway here. It's a powerful reminder that sometimes the most profound solutions to our most modern problems aren't found by inventing something new from scratch, but by humbly looking at the genius that's been all around us, all along. It just makes you wonder, what other secrets are still waiting for us in nature's R&D lab? You know, for millions of years, nature has been running the most sophisticated research lab on the entire planet. And through evolution, it's already solved some of the most complex engineering problems we're still grappling with today. Everything from solar power to structural design. Here's what most people don't realize, though. Nature also left us a blueprint for what might just be the perfect armor. To find it, we've got to go to the Amazon basin. It's a place where life and death are decided in a split second. And that brings us to the central question for this entire explainer. In a river packed with piranhas, creatures whose teeth are legendary for being able to slice through just about anything, how in the world does one fish survive getting bitten? Well, let me introduce you to the Arapaima. This is one of the largest freshwater fish in the world, and it just so happens to share its home with one of the most fearsome predators you can imagine. What you get is this classic evolutionary arms race. It's the ultimate paradox of an unstoppable force meeting a seemingly immovable object. I mean, think about it. The piranha's bite is unbelievably efficient. It's designed to shear right through flesh. So for the Arapaima, every single moment is a high-stakes test of its defenses. Its entire survival hinges on its scales being able to withstand that constant lethal pressure. So, just how tough are these scales really? Well, scientists at places like UC San Diego and UC Berkeley were determined to find out. They actually designed experiments to mimic a piranha attack. What you're seeing here is a sharp point, a lot like a piranha's tooth, being pressed onto a single scale with more and more force. And the results they got were just mind-blowing. The scale can handle an incredible amount of force before it even starts to fracture. It actively resists and bends under the pressure, instead of just shattering like a piece of glass. The Arapaima's incredible strength isn't just about being hard, though. The real secret, the hidden truth, is found when we zoom in. I mean, way in. It's an absolute masterpiece of microengineering. So let's peel back the layers and see what's really going on under the surface. Okay, so the scale has two totally distinct layers that work together in perfect harmony. The outer layer is this super hard, almost ceramic-like shell. It's heavily mineralized, and its whole job is to be the first line of defense, to stop a piranha's tooth from puncturing through. But right underneath that, you've got a second inner layer, and this one's made of a tough but really flexible collagen that's designed to bend and absorb the energy from the bite. In science, this is called a hierarchical structure. And the easiest way to think about it is like a team, where every single player has a specific, vital role. You have the hard outer layer that stops the breach, and then you have the soft inner layer that keeps the whole thing from shattering. That combination of hardness and toughness, it's something that is incredibly difficult to achieve in our own man-made materials. But this is where things get really interesting. The true genius of this design isn't just that there are two layers. It's the specific and frankly kind of mind-boggling arrangement of that flexible inner core. This is the detail that changes everything. Scientists have a name for it, a Booligan-type structure. Now, that inner layer is made of these tiny sheets of collagen fibrils. But here's the kicker. Instead of all lying in the same direction, each layer is rotated just a little bit from the one below it. The best way to picture it is like a stack of plywood, but where every single sheet has been twisted slightly. So why is that so brilliant? Well, imagine a crack starts to form and tries to slice through the material. It can't just go straight down. The moment it hits the next layer, it runs into fibers that are pointing in a totally different direction. This forces the crack to twist and turn and deflect. And that process just rapidly spreads out the energy of the fracture, basically stopping it dead in its tracks. What this quote from the Lawrence Berkeley National Laboratory shows is just how dynamic this armor really is. The research found that those collagen layers don't just sit there passively. Under stress, they actually reorient themselves to better resist the force. The material is adapting to an attack in real time. That is an absolutely incredible feat of natural engineering. Okay, so we've got the blueprint, right? Nature did all the hard work for us. So what happens when our own engineers and material scientists start, well, copying nature's homework? This is where we leave the Amazon River and head into an advanced research lab. Take a look at this. On the left, that's the natural armor of a different fish that uses a similar scale structure. Notice that overlapping diamond-shaped pattern. Now, on the right, that's a 3D printed prototype from researchers. They've perfectly replicated the hard outer layer and the flexible inner one, right down to the overlapping geometry. This is biomimicry in action, taking a design perfected over millions of years and turning it into tech we can actually use. And leading this charge are researchers at world-class US institutions like MIT. They're not just copying what fish scales look like, they are meticulously replicating the underlying mechanics. That perfect blend of hard and soft materials, the overlapping shapes, and those core principles of flexibility and incredible strength. And the results? They're just staggering. Get this, by applying these fish scale principles, researchers have created prototypes that show a 40-fold increase in penetration resistance. 40 times! And they did that while only sacrificing a tiny, tiny amount of flexibility. This is a total game changer for protective materials. So you see, this isn't just some fascinating scientific discovery. This could be the start of a revolution in how we think about protection altogether. Let's just look at a few ways this ancient blueprint could literally shape our future. The potential here is just massive. Imagine it, lighter, more flexible body armor for soldiers that doesn't restrict their movement at all. Or think about spacesuits for astronauts that can shield them from micrometeorites during a spacewalk. We could even see this technology in robotics or as protective coatings for materials we use every single day. And one of the most powerful things about it is the ability to tune the armor for specific needs. You could have more flexibility at the joints and more hardness over the torso. So what's the big takeaway here? It's that nature's genius often isn't about brute strength, but about unbelievably intricate, multi-layered design. The Arapaima's armor isn't just hard, it's smart. It's a dynamic system that actively manages and dissipates force. And that principle, creating toughness through complexity, that's the real blueprint we're borrowing. It suggests that maybe the future of protection won't come from inventing some single, unbreakable material, but from finally learning to build with the same intricate wisdom as nature itself.
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.